Welcome to the lecture, my dear students. In today's lecture, I am going to explain you about the exponential distribution. Exponential distribution is a continuous probability distribution. In the previous classes, we have done the continuous probability distribution, how to find out the mean and how to find out the variance by using the integrations, how to solve it, we have done it. Now in the exponential distribution, how to find out what is the probability density function for this and what is the cumulative distribution function and how to solve the problems, all these we are going to discuss in today's lecture. Before going to the exact exponential distribution, just I want to explain you between the two distributions. That is, there is a close relation, or we can say that the similarities between Poisson and exponential, it looks like the same, but there is a difference. How to let us try to understand what is the difference between those two. The foremost thing is Poisson means it is for discrete. Correct? The discrete probability distribution is Poisson. And continuous probability distribution is exponential. That is the difference, first of all. Now, how to understand in the problems generally, you will be getting the problems, and where you will not be in the question, in the problem, it will not be given that whether it is Poisson or whether it is exponential, suppose. Then how to identify that it is exponential or Poisson means Poisson is discrete, right? For example, you have a number of taxis find the probability of the number of taxis between the first and second hours is given, suppose. The number of taxis, that is what your discrete value, and so it is Poisson. And now coming to in the exponential distributions generally, the time taken between the arrival of two taxis. The first taxi has come at so and so point. Second taxi again has come. What is the time taken between the arrival of the two taxis if it is asked? Then it is exponential, because time is a continuous variable and number of taxis is a discrete variable. So this is what the major difference between Poisson and exponential. Now, as we have done in Poisson distribution, what is the probability mass function? The probability mass function in Poisson distribution is what? E power minus lambda, lambda power x by x factorial. This is your probability of x less than or equal to x. The cumulative distribution function is given by this. Whereas in the exponential distribution, there is a difference between exponential and this one. And now let us see what is the mean of mean in the Poisson distribution is lambda. And what is the variance in the Poisson distribution is also equal to lambda. This we know that, right? The only distribution where mean and variance are the same is the Poisson distribution. Now, when you go to the exponential distribution, the mean is equal to 1 over lambda. That means Poisson mean, when you take the reverse, then it is that is what the reverse is happening. If you are able to understand, we are finding out the number of taxes between the two hours of time, whereas was the probability of the time taken between the two arrival of the two taxes. So definitely this is the other way. So therefore the mean in the Poisson distribution is lambda, the mean in exponential distribution is 1 over lambda, and the variance in the exponential distribution is 1 over lambda square. Okay, so this is what the major difference between Poisson and exponential, so that you will not get confused if I teach both of them like this, so that in the exam, however the question was asked, you can answer with even if it is not given it is not mentioned, suppose it is either Poisson or exponential. Now let us come to the exponential random variable with the parameter lambda. Suppose the function is given by lambda e power. What is this function? This is probability density function given by lambda times of e power minus lambda x, and of course the range is this, and the cumulative distribution function is given by f of x is p of x less than or equal to x is given by probability density function is this, but to do the problems we use the cumulative distribution. What is that? P of x less than or equal to x is given by 1 minus of e power minus lambda x for x greater than or equal to 0. And if I ask what is the probability of x greater than x, suppose, then it is 1 minus of minus this one, right? So it is nothing but e power minus lambda x for x is greater than or equal to 0. So this is what you should understand. So for p of x less than or equal to x is given by 1 minus e power minus lambda x, and p of x greater than x is given by e power minus lambda x for x greater than or equal to 0. So to do the problem in exponential distribution, so this is what the formulas we have to use to solve the problems. Okay, let us now start with the problems now. So what is the large corporate computer network? User logons to the system can be modeled as the Poisson process, with a mean of 25 logons per hour. So what do you mean by the mean of 25 logons per hour in the Poisson process? First you have to understand one thing, that the Poisson mean is given as, that is the value, and you can now say that this logon per hour, so it is definitely the mean of the Poisson. What is the mean of Poisson distribution? That is lambda. But we are not doing the problem using the Poisson distribution. What is the probability that there are no logons in the interval of 6 minutes? So when this is asked, so we have to understand that this is the exponential distribution, because we are going to find out in the interval 6 minutes. So now first thing is you are Poisson, according to Poisson distribution, that means for Poisson process, in the Poisson process the mean is given by lambda is given by 25 per hour. Okay, so it is given that lambda is equal to 25. So now we are going to find out the first question. What is the first question? The probability that there are no logons in the interval 6 minutes. So first of all, this is given in hours, right? So let us rewrite this 6 minutes also, convert this into hours. That means 6 by 60, correct? That gives you 1 over 10, and that gives you 0.1. So 0.1 is what? Hours. So now the question is, what is the probability that there are no logons in the interval 6 minutes? So what is the probability that the logons for more than 6 minutes? That is what you should understand. So what is the probability that when x is greater than 6 minutes? So but what is meant by 6 minutes when you change it into hours is greater than 0.1. So the formula which you have to use for finding out the exponential distribution here, the formula for probability of x less than or equal to x is given by 1 minus e raised to minus lambda x, and the probability of x greater than x is given by e raised to minus lambda x. These are the things you should memorize. Okay. So now what I have got here is probability of x greater than 6. So it is probability of x greater than 0.1. So what is the formula we have to use? E raised to minus lambda x. Now what is the value of lambda? Is 25. So 25 times of x value is 0.1, and therefore it becomes e raised to 25 times of 0.1, which is negative 2.5. And the value for this is 0.082. So this is the answer for the probability of x greater than 6. Okay, as there are no logons in the interval 6 minutes, means below 6 minutes there is nothing. So what is the probability of more than 6 is the question. Now coming to the B bit, what is that? What is the probability that the time until the next logon in between 2 minutes and 3 minutes? So now what is the time in between 2 minutes and 3 minutes? Means 2 less than x less than 3, and of course this is in minutes, 2 minutes and 3 minutes. Okay, but this also you have to change it into the hours. So 2 over 60 is equal to 1 over 30 is given by 0.033, something like this. And 3 over 60 means it is 1 over 20, means it is 0.05 hours. Okay, hour. So now our job is to find out what is the probability of 0.033 less than x less than 0.05. So to find out this, how to do this? This is given by the probability of, when you write down the real line, you will understand very clearly. This is the real line, let us say. The value is 0.033, 0.033, 0.033 and 0.05. It will be like this, right? So now to find out the probability between these two means this whole thing, probability of 0.05 minus probability of 0.033, if you do, then it will be the value between this one. So it is probability of x less than, sorry, so the probability of x x less than 0.05 minus probability of x less than 0.033. This is what you have to find out. So now what is the probability of x less than 0.05 means 1 minus e power minus lambda times of 0.05 minus 1 minus e power minus lambda times of 0.033. Okay, so now what it gives you, that is 1 minus e power, what is lambda value? We have already given that it is 25, right? So it is e power minus 25 times of 0.05 minus 1 minus of minus plus e raised to minus 25 times of 0.033. So this and this gets cancelled. The value is 0.1517. So this is the value of the probability of the time until the next log on in between 2 and 3 minutes. This is what the way to do the problem. I hope you could understand. Let us now go to the next problem. The next problem is the time between the arrivals of the taxis at a busy point is very much clearly given that it is exponentially distributed with mean of 10 minutes. So what it was given here, let us see, the mean of 10 minutes. So what is the mean in the exponential distribution? The mean of the exponential distribution, what is the mean is equal to 1 by lambda and is given as 10 minutes. So what is the value of lambda? Lambda is equal to 1 over 10, that is equal to 0.1. So this is what the value of lambda. So what is the probability that you wait longer than 1 hour for the taxi? So what is the probability of the way that you wait longer than 1 hour? So that means x greater than 1 hour. Already we have given that 1 by the average is in minutes. So greater than 1 hour means greater than 60 minutes if you take. Then the value, the function is what for probability of x greater than means it is probability of x greater than x means it is e raised to minus lambda x itself. So now what it will give you? E raised to minus lambda means 0.1 times of 60. So the value is what? E power minus 1.1 times of 60. The value is 0.002479. So this is what the value of the probability that you wait longer than 1 hour for a taxi. Is it clear? I hope you could understand what is when the mean is given, then you have to write down the mean as 1 over lambda. From that, get the value of lambda and find the values. Let us now take the next problem. The time between the arrival of electronic messages at your computer is exponentially distributed with a mean of 2 hours. So very much clear that the mean of the distribution is equal to 2 hours. So the mean is equal to 2 hours is given. So what is the mean in the exponential distribution is 1 over lambda is 2. So what is the value of lambda? Lambda is equal to 1 by 2 hours. So now we are going to find out the probability that you do not receive a message during a 2 hour period. That means for less than 2 it is 0. What is for greater than 2? Let us see what is it. So that is given by e raised to minus lambda x, and the lambda value is, let us say, half means 0.5, right? So it is e power minus 0.5 times of x value is 2. So let us see what is this value gives you is 0.36788. That's it. I hope you could understand. What is the probability that you do not receive a message during a 2 hour period? Means for x less than 2 it is 0. So getting the messages for greater than 2, what is the probability? So 36% probability is there like this. Is it clear? So let us now see that. The next one is the amount of the time that a watch will run without having to be reset is the random variable having exponentially distributed with a mean of 120 days. So what was given here? The mean is given. What is the mean? Mean is equal to the mean of the exponential distribution. In exponential distribution, what is the mean? The mean is given by 1 over lambda and is given that, right? It is 1 over lambda and is given that mean of 120 days. So 1 over lambda is equal to 120. So therefore what is lambda? 1 over 120 is the value of lambda. Now what is your first question? The first question is you have to be set in less than 24 days. So probability of x less than 24. When it is less than, the formula in exponential distribution is 1 minus e power minus lambda x. So that is 1 minus e power minus 1 over 120 times of x. X means what? 24. So that value is 1 minus e power 24 5s it is, right? 120. So 1 minus e power minus 1 by 5 value, and that is giving you 0.18127. Okay, this is what the value. Let us now go to the next problem. Not have to be set at least 180 days. What do you mean by not have to be set at least 180 days? What do you mean by at least? When we are doing binomial and discrete, we have understood what is meant by at least. At least means it is greater than. So what is the probability of x greater than 180? So that means it is e raised to minus lambda x, and the value is e raised to minus 1 over 120 times of x value is 180. And that value gives you 0.22313. So this is what the probability of x greater than 180. I hope you could understand this. So try to do the problems like this. It is very easy when you understand that what is the question. When you read the question, you will understand what it will, generally it will be asked, what is the time in between the two successive events. What is the time when it is asked? Suppose then it is exponential distribution, and you have to see whether it is greater than or less than. Then according to the corresponding formula you have to do and get the solution. I hope you could understand the problems. Thank you.